In section 8.2, we look at the quadratic formula. The quadratic formula is a formula that allows us to solve a quadratic equation without having to factor and without having to complete the square. So remember, a quadratic equation is an equation of the form ax squared plus bx plus c equals 0. A, b, and c are numbers, and the number a cannot be 0. So we're going to talk about how to solve this equation. We're going to derive the quadratic formula. And the way we do this is by completing the square. So the first step for solving this equation, if we're going to complete the square, is we're going to divide both sides of the equation by a. This is so that we will have a coefficient of 1 in front of x squared. So when we divide by a, we get x squared plus b over a times x plus c over a is equal to 0. And the next step is we're going to subtract c over a to the right-hand side of the equation. And when we do that, we get this. And what we need to do next now is complete the square. So remember, the way you complete the square is you look at the middle number, b over a. We're going to multiply that by 1/2, and we're going to square that. And this gives us b over 2a squared. And this is the number that we need to add to complete the square. So let's go ahead and add b over 2a squared to both sides of the equation. Now, I know it's getting a little bit tedious, but just stay with this process. So the next step is we're going to factor the left-hand side of the equation. Actually, let me first just rewrite it. So we have x squared plus b over a times x plus b over 2a quantity squared equals negative c over a plus b over 2a quantity squared. So now factoring the left-hand side is going to give us x plus b over 2a quantity squared. And on the right-hand side, we're just going to simplify this expression as much as possible. So what we have here is negative c over a plus b squared over 4a squared. And so what I'm doing here is I'm just squaring this fraction. Let's bring this up to the top. So what we have is x plus b over 2a squared is equal to negative c over a plus b squared over 4a squared. And in my next step here, I'm going to multiply the top and bottom of this fraction by 4a. And this is because I'm trying to get a common denominator here. And so what we have is x plus b over 2a squared equals negative 4ac over 4a squared plus b squared over 4a squared. And we can then simplify the right-hand side of the equation. We have a common denominator, and we have negative 4ac plus b squared, which is the same as b squared minus 4ac. Now, on the left-hand side, here we have a perfect square. So to solve for x, we'll take the square root of both sides. This will give us x plus b over 2a equals positive or negative square root of b squared minus 4ac divided by the square root of 4a squared. So we need to take the square root of the top and the bottom. I'm going to take this b over 2a, move it over to the right-hand side, and I'm going to take the square root of 4a squared, which is 2a, and this gives us x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And because we have a common denominator now, we can combine these together into a single fraction. And this is what we know to be the quadratic formula. And I'm quite certain that many of you have seen this before. And this is now a formula that we can use to solve quadratic equations. So if you have a problem that is difficult to factor, or maybe you just don't feel like factoring, this gives you an alternative for solving a quadratic equation instead of completing the square. One other little detail here that I want to talk about is the square root of a square is technically the absolute value, so we should have absolute value signs here. But in the next step, you would put a plus or minus on the other side. Also, down here, the square root of a squared should also have an absolute value, but because we have a plus or a minus, it's unnecessary to put the absolute value. Those are just a couple of minor details, but worth mentioning. So this is our quadratic formula. You need to memorize that, and let's learn how to use it. So here I have stated the quadratic formula in a nice compact statement here. So if we are solving the quadratic equation, ax squared plus bx plus c equals 0, where again a is not equal to 0, then the solutions are x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And I say all divided by because the fraction bar goes all the way across. Both of these are divided by 2a. So let's go ahead and use the quadratic formula to solve this quadratic equation here. So the first thing we need to do is we need to identify a, b, and c. And so in this particular problem, a is 2, b is 3, and c is negative 5. And so a, b, and c are just the coefficients. And we're going to take those numbers and plug them in to the quadratic formula here. So what we have is negative b, which is negative 3, plus or minus the square root of b squared, which is 3 squared, minus 4 times a, but a is 2, times c, but c is negative 5, all divided by 2 times a, and again, a is 2. So again, we're just taking the numbers a equals 2, b equals 3, c equals negative 5, and plugging them into their respective spots in the formula. The rest of this problem is arithmetic. So this is equal to negative 3 plus or minus the square root of 3 squared is 9. Negative 4 times 2 times negative 5 is going to be positive 40. And then divided by 2 times 2 is 4. And now if we just simplify this, 9 plus 40 is 49. So we have negative 3 plus or minus the square root of 49 divided by 4. And this is negative 3 plus or minus 7 divided by 4. And so this is what x equals. We have two answers. So either x is negative 3 plus 7 divided by 4, which is 4 divided by 4, which is 1, or x is negative 3 minus 7 divided by 4, which is negative 10 divided by 4, which is negative 5/2. So these are our two solutions. Now I would like to point out that you could have solved this equation by factoring. And so if you're good at factoring, and if an equation is solvable by factoring, factoring is often much quicker than using the quadratic formula. So we aren't throwing factoring away, we're adding an additional method for those who either don't like factoring or for those problems that are difficult to factor or impossible to factor. Let's look at our second example here. So first of all, when you're solving a quadratic equation, when you identify a, b, and c, you can only do that when it's equal to 0. So we need to set this equal to 0. And the way we do that is we just add 1 to both sides. And so when we add 1, we get 3x squared plus 8x plus 1 equals 0. So now a is 3, b is 8, and c is 1. And when we plug those into our quadratic formula, we get x equals negative b, which is negative 8, plus or minus the square root of b squared, which is 8 squared, minus 4 times a, which is 3, times c, which is 1, all divided by 2 times a, and a is, again, 3. And from here we simplify, so this is negative 8, plus or minus the square root of 8 squared is 64, and then negative 4 times 3 times 1 is negative 12, all divided by 2 times 3, which is 6. Keep on simplifying. We have x equals negative 8 plus or minus the square root of 64 minus 12 is 52. And then now we have to simplify this. And so the important point to make here is do not cancel a common factor between 8 and 6 until you have simplified the radical. Do the radical first. So this is negative 8 plus 2 radical 13 divided by 6. So where this comes from is 52 equals 4 times 13. And you know the square root of 4 is 2. So now what we can do is we can cancel a factor of 2 in each of these numbers here. So we're going to divide 6 by 2, divide 8 by 2, and divide 2 by 2. And so when we cancel that common factor of 2, we get negative 4 plus or minus the square root of 13 divided by 3. And again, there are two answers here. So one answer is x equals negative 4 plus the square root of 13 divided by 3. Or the other answer is x equals negative 4 minus the square root of 13 divided by 3. And these answers can't be simplified anymore. So notice that these answers are not quite as nice as the answers that we had in the last example. These answers here. Well, these answers were nice because we were taking the square root of 49, which we know is 7. The square root of 13 is not a perfect square. So you can either leave your answers like this, or you can approximate your answers. And so you can plug these answers into a calculator, and negative 4 plus the square root of 13 divided by 3 turns out to be negative 0.13 if you round to 2 decimal places. And the other answer, negative 4 minus the square root of 13 divided by 2, is negative 3.80. And so these are the approximate answers. Sometimes you'll be asked to give exact answers, and sometimes you'll be asked to give approximate answers. And if you are asked to give approximate answers, it's important to pay attention to the number of decimal places that they ask you to give. And actually, I just figured out that I made a small error here plugging this into the calculator. It was an input error. But this first answer here should be negative 0.20. Sorry about that. Okay. Let's go ahead and move on to the next set of examples. So let's continue with the quadratic formula. Let's use the quadratic formula to solve the quadratic equation x squared minus 6x plus 13 equals 0. Let's remind ourselves that there's a coefficient of 1 in front of the x squared. And so we have a equals 1, b equals negative 6, and c equals 13. And if we plug those numbers into the quadratic formula, x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 13, all divided by 2 times 1. So I'm just plugging the values of a, b, and c into the quadratic formula. This gives us 6 plus or minus the square root of 36 minus 4 times 1 times 13 is 52, and 2 times 1 is 2. And this is 6 plus or minus the square root of 36 take away 52 is negative 16. So pay attention to the fact that this is the square root of a negative, which you know gives us an imaginary number. So the square root of negative 16, you should know, is 4i. So we simplify the radical first, and then in our last step, we divide by 2 to both of these. So 6 divided by 2 is 3, and 4i divided by 2 is 2i. And you can leave your answers like this on paper, but realize there are two separate answers, and they are 3 plus 2i, right? That's one answer, or x equals 3 minus 2i. And another thing that I want you to notice about the answers is that the two answers here are complex conjugates of each other. And that's not a coincidence. That always happens. Okay, in our next example, very similar. First of all, notice that it's not set equal to 0. This is a problem. We have to set it equal to 0. But also, we have a bunch of fractions here, and we don't want to deal with fractions. So the first thing I'm going to do is just multiply both sides by 5. This will give us 5x squared equals 13x plus 6. Now we'll set it equal to 0 by subtracting 13x and subtracting 6. And now we can plug in the values of a, b, and c. You don't have to write down the values of a, b, and c like I did here. You can simply look at the equation and identify the values of a, b, and c. So x is going to equal negative 13 plus or minus the square root of negative 13 quantity squared minus 4 times 5 times negative 6, all divided by 2 times 5. Doing the math, we have 13 plus or minus the square root of 169 plus 120, right? So I'm doing negative 13 squared is 169, and 4 times 5 times 6 is 120, and a negative times a negative is a positive. And these little nuances in here are very important. Most mistakes that are made in the quadratic formula happen inside the radical, so be careful. This is all divided by 2 times 5, which is 10. Keep simplifying. 169 plus 120 is 289. And 289 is 17. It's a whole number. So we have two answers. We have x equals 13 plus 17 divided by 10, which is 30 divided by 10, which is 3. Or the other answer is x equals 13 minus 17 divided by 10, which is negative 4 divided by 10, or negative 2/5. And there are our two answers. So in section 8.3, we're going to talk about the quadratic formula a little bit more, but this time we're focusing on a certain part of the quadratic formula. And this part is called the discriminant. And then after we talk about that, we'll take a look at some equations that fall into the category of quadratic forms. So once again, we have our quadratic equation. And when we go to solve that equation, we use the quadratic formula. The most important part of the quadratic formula is the part that is inside the radical. And this thing inside the radical is called the discriminant. And the reason it's called that is because it tells us things about the solutions to the quadratic equation. So the discriminant for a quadratic equation is b squared minus 4ac. It's the number that is inside the radical here. And a lot of times I'll abbreviate that with a capital D standing for discriminant. So what we know is that for a quadratic equation, if the discriminant is positive, there are going to be two real solutions. So what that means is when you're solving the equation, if the number in here ends up being positive, you will get two real number solutions. If the discriminant is negative, there are two non-real solutions, meaning complex solutions. Well, that's because if this number is negative, you're taking the square root of a negative, and we know that's not a real number. If the discriminant equals 0, there is only one real solution. You don't get two solutions if the discriminant is 0. And finally, let's go back to the discriminant being positive. If the discriminant is positive, and if that number is a perfect square, then our two solutions are going to be two rational solutions. Otherwise, if your discriminant is not a perfect square, you're going to get two irrational solutions. So let's do some examples where we can use the discriminant to classify our answers. So let's take a look at this first equation here. And again, I just want to classify the solutions. I'm not actually going to solve the equation. So to classify the solutions here, we need the value of the discriminant, which again is from the formula b squared minus 4ac. In this particular quadratic equation, b is negative 5, a is 1, and c is negative 14. So remind yourself that there's a 1 here. And when you do b squared minus 4 times a times c, this is equal to 25 plus 4 times 1 times 14 is 56. And if you add those together, you get 81. So our discriminant is 81. 81 is a positive number. So we know there are two real solutions. However, 81 is also a perfect square. So not only do we know that there are two real solutions, we know in fact that there are two rational solutions. Now, if you're wondering what that means, two rational solutions, that means we have two nice solutions. Fractions, meaning that your answer will not have a square root involved in it. So you saw some examples of this in the last section when we were solving equations. Right? Let's look at the second example. Again, let's use the discriminant, and let's remind ourselves that this also has a leading coefficient of 1, and the discriminant is b squared minus 4 times a times c, and this is 16 minus 20, which is negative 4. So in this problem, our discriminant is negative 4. If your discriminant is negative, that means your solutions are two non-real solutions. And what that means is that your solution is going to have an imaginary number involved with it, right? It's going to have an I, okay? And again, that's because when you use the quadratic formula, if your discriminant is negative, it means that you're going to be taking the square root of a negative. Let's look at the last two examples here. So again, let's calculate the discriminant. In this problem, the discriminant is b squared, which is 2 squared, minus 4 times a, which is 3, times c, which is negative 11. This is 4 plus 4 times 3 is 12, and 12 times 11 is 132. So this discriminant is 136. 136 is a positive number. So if it's positive, that means we have two real solutions. But when it's positive, you have to ask yourself the additional question, is it a perfect square or is it not a perfect square? So let's remind ourselves in the first example here, 81 was a positive number, but it's also a perfect square. Well, 136 is positive, but it is not a perfect square. So you will have two real solutions, but this time they will be irrational. Irrational means not nice. It means that you will have a square root in your answer. Okay, and finally, let's take a look at our last problem here. Let's compute the discriminant. Discriminant is b squared minus 4 times a times c. So we need to multiply negative 24 times negative 24. That should be 576. Please verify that. Minus, and then we have 4 times 9 times 16. Well, 4 times 9 times 16 is 576. So the discriminant here is 0. And if the discriminant is 0, this means you are going to have one real solution. And it will actually be a rational solution because 0 is a perfect square. Okay? So the discriminant allows us to classify the types of answers that we're going to get, which may seem a little bit ridiculous to some of you, because in the time that it takes to classify your answers, you can often just solve for your answers. But it is something that is worth talking about. All right, so the last part of this section we're going to devote to something called quadratic forms. A quadratic form is an expression that resembles a quadratic but is not necessarily a quadratic. So a quadratic form is something that looks like a times u squared plus b times u plus c, where this u may not simply be a variable, it might be a variable expression, okay? So, for example, our first equation here, x to the 4th power minus 13x squared plus 36 equals 0. this is not a quadratic equation, because a quadratic equation is a second-degree equation. This is a fourth-degree equation. However, this is a quadratic form. You can see that this equation resembles this expression here. So what we can do is we can rewrite the equation as follows. X to the fourth is the same as x squared squared. And then we have minus 13x squared plus 36 equals 0. Now, what if I were to make a substitution here? Just go with me for a minute. What if I were to say, let u be equal to x squared? If u is equal to x squared, then u is going to take the place of x squared in both of these spots in the equation. And so if we let u equal x squared, we actually get u squared minus 13u plus 36 equals 0. So by making a simple substitution, we've taken an equation that wasn't a quadratic equation and we turned it into a quadratic equation. This is what it's meant to have a quadratic form. So let's go ahead and solve this quadratic equation. We can solve it by factoring fairly easily. We have u minus 4 times u minus 9 is equal to 0. And then we can set each of those factors equal to 0. And we get u equals 4 or u equals 9. However, we're not solving for u. Remember, we were solving for x. We made a substitution to simplify our equation. So now that we're done solving for u, we have to go back and say, but u was really representing x squared. So I'm going to replace u with x squared again. And that gives us x squared equals 4 or x squared equals 9. And we can then finish this problem by taking the square root of both sides. And that's going to give us x equals positive or negative 2 or x equals positive or negative 3. So in the end, we have 4 solutions. We have negative 3, negative 2, positive 2, and positive 3 if we write them all in order. We can apply the same technique to the second problem. The second problem here looks a little bit more complicated. But if you recognize that you have the same expression, 1 minus 4x here, and 1 minus 4x here, we can make a substitution. We could let u represent 1 minus 4x temporarily. We can then replace 1 minus 4x with u. And if we make that replacement, we get 3u squared minus 2u minus 5 equals 0. And we can solve this equation however we want. I'm going to use factoring because I think factoring is a little bit quicker. And you can double check my factoring. I'm not showing the work on factoring because we've already talked about that. I don't want to make this video too long. But once we have it successfully factored, we can set each factor equal to 0, and then we can solve for u the traditional way that we do here. But then remember, we're not really solving for u. We're supposed to be solving for x. We made the substitution to make a complicated equation look simple. So now we need to say, well, u is really 1 minus 4x. And so 1 minus 4x is going to replace the u. And from there, we can solve for x. And you can do this any way you like. I think I'll multiply both sides by 3. That will give us 3 minus 12x equals 5. And then I'll subtract 3, which gives us negative 12x equals 2. And finally, I'll divide by negative 12. And our final answer here is x is equal to negative 1/6. So that's one answer. And then we have u equals -1. Let's replace u here with, again, 1 minus 4x. So we have 1 minus 4x equals -1. And if I subtract 1 from both sides, this gives us -4x equals -2. And dividing by -4, we get x is equal to 1/2. And so we have two solutions, -1/6 and +1/2. Our next example is probably the one that students like the least, and it's because we have these fraction powers. But let's remind ourselves that t to the 2/3 is the same as t to the 1/3 quantity squared. Because if you multiply these together, you get 2/3. And then plus 5t to the 1/3 minus 6 equals 0. And so from here, we can do the same technique. We can let u be equal to t to the 1/3. And so u is going to replace each of those, which gives us u squared plus 5u minus 6 equals 0. And we can solve this by factoring. And when we do, we end up getting u equals -6 and u equals +1. But then from here, remember, it's really not u what we're solving for. We're supposed to be solving for t. So I'm going to put t to the 1/3 back in here for u. So we get t to the 1/3 equals -6, and we get t to the 1/3 equals 1. Now, how do you solve for t if you have t to the 1/3? Well, remember, a 1/3 power is the same as a cube root. So if you want to get rid of a 1/3 power, you need to cube both sides. And so when you do that, you get t equals, and then -6 to the 3rd power is -216. Same thing for the other equation. Cube both sides, and you get t equals 1 to the 3rd power, which is 1. So we have two answers there. Now our next problem is a little bit of a throwback problem. We have a rational equation. And do you remember how to solve a rational equation? What we should do here is identify the least common denominator, which is 6x times x minus 3. And then we're going to multiply that least common denominator to each term. And so it's a little bit time consuming, but once we multiply that to each term, we can then cancel common factors. So 6 cancels 6, x cancels x, and x minus 3 cancels x minus 3. And from there, we can multiply this out. This is x squared minus 3x, plus, then we have 6x minus 18 here. And on the other side, we have equals 6x times 2 is 12x. Combine like terms, we have x squared plus 3x minus 18 equals 12x. Subtract 12x from both sides, and this gives us x squared minus 9x minus 18 equals 0. So we had something that didn't look like a quadratic equation at all, but it ended up being a quadratic equation. Now, how do we solve this quadratic equation? Well, it's a little bit tricky. You got to be careful, because it looks like you can factor it, because 6 times 3 is 18, and 6 plus 3 is 9. But the problem is we have negative 18. So actually, 6 and 3 don't work here. You have to be very careful. So I'm going to use the quadratic formula to solve this. So we'll get x equals negative 9 plus or minus the square root of negative 9 squared minus 4 times 1 times negative 18, all divided by 2 times 1. This is 9 plus or minus the square root of 81 plus 72 divided by 2. And this is 9 plus or minus the square root of 153 divided by 2. And 153, does that simplify? Well, actually, I think it does, because 153, if you divide that by 9, 9 goes into 153 17 times. So it's 9 times 17. So we can break this down into 3 radical 17. So again, if you're a little confused here, what I'm doing with the square root of 153 is I'm taking the square root of 9 times the square root of 17, and the square root of 9 is 3. And so here are our 2 answers, and of course you could write those separately. Okay? All right, one more problem. So for our last example here, we're going to go back and look at a quadratic form once again. And this time I'm going to solve it a little bit differently. Rather than make a substitution, I'm just going to factor this. We know that x to the 4th is x squared times x squared. We know that 45 is 5 times 9. And if we have a negative 9 and a positive 5, that will give us the negative 4 in the middle. So just take a minute to verify that. And then from here, what we can do is simply set x squared plus 5 equal to 0, and we can set x squared minus 9 equal to 0. And x squared minus 9 is pretty easy to solve if we add 9 to both sides. And then if we take the square root, we will end up getting x equals positive or negative 3. And then the other equation, x squared plus 5 equals 0, you can solve this the same way. You can subtract 5 from both sides and then take the square root of both sides. But when you do this, your answers aren't nearly as nice, because the square root of negative 5, first of all, is an imaginary number. So the negative comes out as an I, so we get I radical 5. And that's actually all we can do, because radical 5 does not simplify. So you end up getting 4 solutions, and they are, if you write them sort of in order, you have negative 3, you have positive 3, you have negative I radical 5, and you have positive I radical 5. So as you're starting to see in this section, your answers to these equations can be rather involved. You get all different sorts of answers, right? Sometimes you get nice answers, sometimes radical, sometimes complex numbers. So don't have any assumptions about what the answers should be. Just make sure that you watch all your steps and do everything correctly, and you should end up with the correct answers. Okay, so that concludes this section.